You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
Hey guys, welcome back to the series, Making Data Simple. This is Al Martin here. I'm the lucky guy that gets to host this. Today's topic is going to be machine learning, and we'll probably dive down into machine learning hubs. Most of you that are listening probably know what machine learning is, but my simple definition, and I will let my guest that I introduce in just a moment give a better definition, but my simple definition is machine learning gives computers the ability to learn without being explicitly programmed. And the cool thing about it is, at least for me, being an IBMer, is I believe that term was actually coined by Arthur Samuel in 1959. So we've been doing it a while, and it's really about prediction making in my mind. But again, I'll let the experts define it, with the use of computers, models, algorithms, and that kind of thing. With that, and without further ado, I'll introduce my guests. I got two today, so this will be a little different than what we've done in the past. Jorge Castañón and Óscar Lara-Yejas. I apologize in advance, guys. I'll let you guys introduce yourself. But they lead the Machine Learning Hub here at IBM, and they know much more about machine learning than I, so they're going to straighten me out today. And the cool thing about this, guys, is I've done this so I get to learn, right? I can put all my ignorance aside, and I can ask you guys questions and get smart. That's the deal. So, Jorge, let me start with you. Could you quickly introduce yourself? And you might say your name again just so we get it right for once. And then your background on machine learning, and then I'll turn it over to you just the same, Óscar.
For sure, Al. Thanks for having us. My name is Jorge Castañón, and I've been at IBM for the last 3 years. We started with the Machine Learning Hub early this year in February. And before joining IBM, I did my PhD in machine learning and numerical optimization at Rice University. And yeah, so this year we've been working on the ML Hub. And of course, Óscar and I, we're colleagues here at the ML Hub.
Fantastic. Óscar, a little introduction from yourself.
All right, absolutely. So my name is Óscar Lara-Yejas, and by the way, you pronounced it just perfectly. So congratulations to you. I know it can be tricky sometimes. But that being said, I've been in IBM for a little over 5 years. Matter of fact, last week was my 5th year anniversary here in IBM. And
congratulations.
Thank you so much. I still love the hills here at the Silicon Valley Laboratory. It's pretty beautiful nature around here. And initially, I joined as part of the big data team, working on some technologies for large-scale machine learning and analytics. And now part of the Machine Learning Hub, very excited, very happy to be a data scientist and be part of this initiative. Before that, I did my PhD in computer science and engineering at the University of South Florida in Tampa. Go Bulls, by the way. And yeah, really excited to be here sharing some of our experience and little knowledge. I would say you are totally overselling us, but happy to be here sharing some of our thoughts with you.
Fantastic. I guess we've established that the only person without a PhD at the table here is myself. I'm feeling a little bit inferior at this point in time. Good. So that'll lead me to my next question then. So how do you go about being an expert in machine learning? Maybe we have some students out there listening. How do you get on that path? How do you stay on that path? What inspires you to be on that path? Could one of you, I'll just, anyone, Óscar, why don't you take this one first? How do you jump into that path?
Absolutely. I would say that the first thing is to have passion or an interest about something, right? Once you have the passion, I would say you can accomplish pretty much anything. So in my specific case, at least, it just fascinates me how you can get insights from data. To me, that's what machine learning actually is, right? You have data, and our customers have tons and tons of data. Many of them, they already have DB2 products and all sorts of data. But then data is useless unless you can get insights out of them. And that's what specifically fascinates me about machine learning, the fact that you can learn stuff from new data, right? And use that things that you learn to make predictions or to make decisions in the present and the future. I would say, of course, that taking formal training in terms of taking classes at university. I took a data mining class. I took a Bayesian optimization kind of a course as well. Taking classes is of course very useful, but I would say machine learning is something that you only learn when you do it, right? When you can know so many equations, you can know so the most complicated algorithms, but there are some nuances and some kind of common sense when you approach every single problem that you can only develop by doing it, by working with the data, writing the algorithms, and making things happen. So it's a very hands-on kind of field. That would be my take on it.
So Jorge, when did you know that machine learning was your career path? And hell, you've got a long career ahead of you, but in terms of where you are now, how did you know that this was the place you were going to be, and what got you here?
Yeah, good question. I think at the beginning, or maybe at halfway of the PhD, I started to work on machine learning related problems with medical imaging. So I think that's where I started to see how important it is to use historical information to build machines, to build algorithms, to build predictions. So it was very important for me to realize that I can use historical information of, for example, brain images to train a model to be better and have the patient less time on the machines, just because you have seen history of brains before. If you haven't seen that history, then you will keep the patient more time. Maybe your prediction is going to be less accurate, and so on. So that's where I understood how important that concept of having or of learning from examples. And I really like your definition of machine learning, because that's what it is, right? So you take history, you take examples, and you provide that to the machine to learn, rather than coding it explicitly. I think we're completely in line with that definition.
That's right.
So let's hit that one more time. So what is machine learning? If you could repeat that one last time, just so we're clear. And then what is it not? I mean, if you can answer that question.
Sure. So machine learning is the ability to learn from examples, right? So it's always examples that you need, examples of data. In the case of supervised machine learning, for example, you always need pieces of information with the label of the correct thing that you are trying to predict.
The ground truth.
The ground truth, right? So if you don't have examples, if you don't have historical data, then you cannot do any machine learning.
Right.
What is not? That's a question that we have to answer all the time at the Machine Learning Hub, because a lot of our customers and colleagues come to us and they just think that they can solve every single problem with machine learning. So the first conversation that we have with people is like, this is what machine learning is. This is what an example looks like. This is what we need to actually start to build a machine learning model.
Yeah. In other words, what it's not, I would say, is it's not the holy grail, right? That's what people think when they approach us. It's just you brew the data into machine learning, and then magically you get all the insights and answers, right? So that's what it's not, and we have to do a lot of education, a lot of awareness on that.
Sounds like to me that there's, like anything, particularly new technologies, there's a lot of information out there. When I look at this, I kind of look at, I think we're in an I think this is an overused term, just like the next one I'm going to use, but we're in an unprecedented time or era where we often say data, or overuse the term that's saying that data is the new natural resource. And I think there's a tendency for myself as well to say, yeah, whatever. I mean, we've heard that before, blah, blah, blah. But when you start thinking about it more deeply, you realize, I mean, when you really think about it, that everything we're doing today, darn near everything is leaving a digital footprint, from credit to mobile to online to your purchasing. And we're feeding all this data into machines, like machine learning. And I think that creates a lot of worry and fear, which then promotes the information that you're talking about out there in the industry. The first one that I always find is funny is that the first fear that I hear a ton about is machines are going to take our jobs and we've got to do something about it. What are we going to do? And I think I'll give credit to our chairman, Ginni Rometty, and her definition is augmented intelligence, not artificial intelligence, because I think, we sit side by side with that machine learning to make it useful. But the interesting thing to me, and this is what I want to get your feedback on, is what I don't hear as much about the bigger concerns that I would have, and that is around ethics. I mean, by example, on one hand, we need data. The more medical data, by example, we feed into some of these algorithms, the better we're going to be able to find cures. But then on the other hand, you're thinking, well, do I want to have my personal medical data out there for, you don't know where it's going to go, who's going to consume it. And then it goes beyond that in that literally this morning I was listening to a thing about the European Union, and they've proposed the idea of e-persons, where you'll have electronic persons, where you'll have a robot that is responsible, and it could even be paying its own taxes at some point in time. And for me to think a robot is liable is ridiculous. I mean, again, it goes back to the augmented intelligence. Always a human is responsible, leveraging the output of machine learning or otherwise. If that's not enough, I'll say one more thing, then I'll turn it over to you guys. I want to hear your take on ethics. My other worry is that, if anything, machine learning could make us lazy. In that, just like you said, we think it's the Holy Grail, or there's many people that come in and think it's the Holy Grail. It's kind of like my backup camera or the backup camera they have on cars now. I'm always worried about my children. They just rely on that backup camera. It's got to work. It's got to work. And they forget, where we used to look at mirrors, we used to turn our head to make sure nothing's there. We're going to continue to rely on machine learning in the same way. And I have to admit that my backup camera the other day was covered up with mud, and it was going off, and sure as heck, it wasn't my kids, it was me that backed into the car behind me. So I'm guilty as anyone else. So talk to me a little bit about, and I'll start with you, Oscar, about the ethics. What do you see in terms of augmented intelligence, what it means? What do you think we're going to have to be more concerned about today versus the fact that they're just going to take our jobs?
Absolutely. And I completely agree with you. The way I see machine learning and artificial intelligence is as tools that help humans to become better at their jobs rather than, something that's going to threaten or jeopardize people's, works. So just to give you an example, right, Watson is doing a lot of stuff with healthcare and understanding tons of research papers to try to come up with potentially cures for cancer and many other diseases, right? And something that a doctor would take a doctor, days or weeks to understand and process, machine learning algorithm may do it much more quickly, therefore making the doctor much more productive to make these kinds of decisions in terms of diagnosis and so forth, right? I also heard that, there's this system that helps musicians to compose music. So that's called a Watson Beat. And one famous artist, actually I went to his concert last week, and he's using this system to write music himself, And I don't believe that we're gonna reach a point where, composers are gonna be kicked out of the jobs by robots. But on the other hand, it's more like, a composer may use or may, leverage inspiration from this system that understands different musical components in order to be more productive in their composition or music creation process, right? And I somehow associate this era with the Industrial Revolution, right? Before the Industrial Revolution happened, there were a lot of people doing manual labor, very heavy lifting in order to build stuff, in order to do transportation, in order to do many, many other things. And at that point, what happened was that many people lose their jobs, quote unquote, but it allowed, society and to advance technologically, and those people who lost their jobs at the time, they had to be reassigned to other jobs, right? So I guess there's a lot of training. There may be certain jobs, for example, it is known that for example, the drivers are the number one job in the U.S., right? And you may argue, if we have self-driving cars, right, those people are going to be displaced out of their jobs, and that's of course a concern. My take on that would be, many people will need to perhaps learn new skills in order to be able to perform all the types of jobs, if that's the case. So I guess it's two different fronts. One in terms of augmenting, and improving the skills of people, such as the case of the doctors, such as the case of the musicians, and so on and so forth. And on the other hand, I would say that some people, they may need to learn new skills in order to perform different kinds of jobs that are no longer going to be available for humans, that are going to be totally automated by machines.
So that, if there's anything, I agree with you. I think we're in the era of continuous learning. I mean, you don't just do one thing and then stay with it for 50 years, maybe like grandparents did. You're going to have to learn new skills and continue to, almost in agile fashion, do continuous learning. So Jorge, what do you think the biggest challenge is going to be moving forward in the era of augmented intelligence and machine learning? What do you think is the real concerns that we should be addressing?
Yeah, so I see machine learning, the era of having machines helping you rather than replacing you. So I'm in line with you guys. And it's funny that I just saw a TV series from Netflix. It's a 6-episode TV series. It's very new. It's called Yokio. It's very fun. But what I want to talk about is that the main character of this cartoon, it's like anime-based cartoon, and this guy has a robot with him all the time, and that robot is assisting the main character all the time on everything that he's doing and he's not doing, right? And at some point of the TV series, the robot opens, and it turns out that there's a human inside the robot. And then the guy is so surprised, right? Like, how come I didn't know you were there? And then this person is saying, like, yeah, so I've been here all the time. The robot is only filtering, and it turns out that this human is actually not nice, right? It has no filter. Like they don't kind of like, they're not friends to each other, but the robot and the guy is just like super friends, and it's very funny. I think that's the way it's going to go, right? But but I think that, so we need to actually teach these machines correctly, right? So if we're filtering things, going back to ethics, right? What to filter, what not to filter, right? As a data scientist, I think we have a big responsibility, right? Sometimes some of the things that we're working on are so difficult that it's our responsibility to be super transparent. And, in terms of ethics, maybe you understand things that not everyone is understanding. So you have the responsibility to, to share that information in a very clear way, like crystal clear, like what are the limitations, what is this algorithm for, if the predictions are good in this range, and so on, right? So that's the big thing that I think in terms of ethics as a data scientist.
Fantastic. That's a good example. I'll have to check that out. Hey, so let's transition into machine learning hubs, because I know that's where you spend a lot of your time right now. Not so much looking for a sales pitch, but what is it? Why do you think it's necessary? And what kind of outcomes are you able to drive within these quote unquote hubs? Can you tell us a bit on that, Jorge?
Yeah, so what we do at the Machine Learning Hub is to try to close a big gap that we have right now. And that's the fact that there's not enough data scientists, right? So there's it is expected to in 2018, we're expecting to have 500,000 data science roles needed, right? So, and we will only have 200K data scientists out there. So 40% only, and I think that's only in the US, but it can translate to all the world. And so what in the Machine Learning Hub, what we're trying is to close that gap, right? So maybe there's some companies approaching us, they have data, they have a lot of passion to get value out of their data. They don't know how, right? So they come to us, we spend those 2 or 3 days with them, and we help them achieve one single model, one simple use case we solve with them. And then after that, maybe they can take it from there. They can build more models. They can be more precise. They can incorporate more data. But I think the main mission of the ML Hub is to close that gap and to be more transparent about how data science is applied.
So, Oscar, so describe to me some of the common issues you find as clients come in. They say, look, I need help. I need help with machine learning. They come into the hub. Who do they usually come with, I guess, is the question I would have. And what are the common problems that you see, and then how are they reconciled?
Absolutely. So as we mentioned at the very beginning, one of the most difficult problems is to understand what machine learning can do and what it cannot do, right? And in many cases, people come to us with big dreams, and in one of the most common challenges is to nail down what is it that the machine learning problem is going to look like, identify the problem, and then identify what data is going to be used to solve such problem. And in many cases, there are issues with data access, for example. The data is very sensitive. For example, in this use case we were working on with a healthcare company, they have patient records, right? So we had issues that, the data couldn't get out of the mainframe because of the sensitivity of the data. And we actually, instead of, in that specific case, instead of the customer coming to us, we had to actually travel to the site because the data couldn't get out of there. So data access is an issue for sure. Understanding or trying to nail down a machine learning problem is also an issue. Data curation is also an issue. In many cases, the data are simply not clean. And these things that we take for granted in the relational world, such as having the data schema available, having the primary keys, having foreign keys, and this kind of relationships among tables. In this, machine learning use cases, you don't have that, and oftentimes you get a data set that you don't know what the columns are, you don't know what the data types are. You have a lot of missing information, missing values. Instead of having just one single data source, which is, most machine learning algorithms, they take as input one specific data set. Instead of having just one, you usually encounter tons and tons of files that you have to somehow reconcile, put together, clean, and all those things, right? And those become challenges that even before you being able to train your first machine learning model, you need to, do a lot of data cleansing, data preparation, and of course, understanding also some of the nuances of the domain itself it may be challenging as well. Because we are machine learning generalists, but we are not experts in finance, we are not experts in healthcare, we are not experts in biology, and in many cases we have to learn from all these domains in order to be able to build good machine learning models. And it's fun as well, because not only you learn about machine learning, but you end up learning about all these specific domains, so which is pretty cool.
Here's the thing that confuses me about this, and maybe Jorge, you can help me. I get what you're saying. What I thought I heard you say is one of the biggest challenges you face is actually getting at all the disparate sources of data, making sense of that data, cleansing that data, ingesting that data. Could go on and on. But I got to imagine if I'm a client and I'm coming into these hubs, I bet they're thinking on the opposite end. And maybe I'm wrong here. You guys tell me in terms of what your experience is. And what I mean by that is they probably have what they feel is a handle on their data, though they have to convey that to you and convince you of that. But I bet I just would assume that they would have come in from a client perspective, and they're more worried about how am I going to find the right programming language to do this, the machine learning? What language should I use? How do I create these models? How do I base these models off of? Am I right in that, or do a lot of the clients come in and are concerned about everything top to bottom?
I think that's a very interesting topic that you bring. We have both, I think. Sometimes the customer, they already have the data that they want to use. Sometimes they already have even like the idea of if you need a classifier or a regression and so on. So in those cases, we can really start like right in the middle or with a lot of advantage. We can use our time much better. But yeah, sometimes the customers come and it's they are just starting. Maybe they have just a little bit of data, right? So the first thing to understand is that the data limitation can only take you have certain. I mean, going back to the machine learning definition, right? You learn from examples. You learn from history. If you don't have history in the data, you will not learn that part, right? So if the data is a limitation, then you need to think about, okay, if you don't have a good representation of your data in this data set, then you cannot expect that this model will work for any case, right? So sometimes we need to spend a lot of time at the beginning to just make clear that the model that we're building, it's just based on this data set, and that it's very important that if there's another data source that you need to connect, or there's more data that you need to use covering many years, for example, then it's always good that they go back and actually build a model that is more comprehensive. But definitely we have customers at very different points, like. So it's pretty open, and it's always a challenge, even though we have customers in different parts of the pipeline.
Is face-to-face absolutely required with these, or can you do them remotely, or is it just your preference? I mean, what's your thoughts on that?
I think face-to-face is a must, at least at the beginning. I think there's 3 reasons because of that. I think trust is the first one. Because you will not just give the data to anyone, right? So I think you need to, my second point is to build a relationship, right? So you build a relationship and you start to trust the people, right? Maybe you trust IBM, and with everything in hand, with NDAs and all that, then of course you are legally okay, but still you're going to kind of like get naked in front of people when you share the data, right? It's something like that. You really need to like feel comfortable with someone else to get into that point. Yeah, so I think trust and building it's actually 2. I think trust and building the relationship goes in the same bullet, and the second one is clarity. Sometimes customers come and you need to clarify what's the goal of those 2 days, or what's achievable in those 2 days, and to be in line. Like sometimes if you're not face to face, it's very easy to not be clear, and maybe you go and solve a problem that is not the one that they need a solution for, right? So clarity is one, and the other one is trust and building relationship, right? You will definitely trust more someone that you have seen, and with all the legal implications on the table, of course. But yeah, so just having that face-to-face will help you build the relationship, and they will be more comfortable sharing the data.
Yeah, I think that goes back to the concern with data I had. I think those are some of the bigger issues is people willing to share their data, the ethics around the data, relying too much on machine learning. Again, it keeps coming back to that. For me. So let me ask you this as we kind of wrap up, and like with any topic, it seems like, we may have to bring you back and do a deeper dive on some more questions on this, because we could go on forever. But Oscar, could you describe a wow moment or something? I mean, something, by example, an outcome that was just thrilling as a result of, the Machine Learning Hub or your work with a client. Give me something that you just uncovered that is just like brilliant.
Yeah, so one of the very first engagements that we had was with a healthcare company. And that was the one I was actually telling you that we had to go on site because of the, because of the data being so sensitive. patient records and all that. And it was very rewarding because of different reasons. I would say the first one is, for us data scientists and being journalists as well, we get to work in different domains like, financial services, manufacturing, healthcare, and so forth. But somehow healthcare, it gives you this kind of extra reward that you are somehow helping or contributing to society by improving people's health with your work, right? So that was actually very interesting for us. So in that specific use case, we were given data from patient medication compliance, also from patient blood tests and some other different kinds of medical tests. And we were able to create a model to predict which patients were at the highest risk of, either not complying with their medication, or we're more prone to get certain diseases and that kind of stuff, right? So, and it was very interesting, not only because of the fact that we were able to build an accurate model from the machine learning, technical perspective, but also because of the fact that, it's rewarding to feel that your work is contributing to improve people's health. And also we were working with a medical doctor, right, who was advising us all the time and giving us great feedback on the topic. And it was also a very good collaboration with him. I mean, this doctor being also a very nice individual and very eager to, use machine learning to improve people's health. Just simple as that.
Yeah, and I think the very wow moment was when this doctor came and saw the results and saw the plots and saw the predictions, and in his head it was all making sense. Yes. and he would transmit that to us, so it would be like a very, very interactive session, and we would get to results really fast, like intraday. It was really amazing.
I read a book. I can't remember the book. I think I can't remember the book. Very interesting. It was talking about doctors' assessment of the human brain. And it showed they went through many, many experts in the field. They would assess these brains for, malignant or not tumors. And essentially they couldn't, They sometimes they wouldn't even come up with the same results themselves the second time they went through and looked through the information, given a case for machine learning to help guide them, because it's going to be, very objective, just very precise, statistical and measure, etc. Anyway, let me ask this, and then I want to go to a lightning round. Any last word that you guys have on machine learning that you want this audience to understand, know, that you feel you wouldn't be right if you didn't say a couple comments on it before we leave?
It's very good to get that introduction course of machine learning before trying to apply it. The conversation turns much better after, the quality wise, to know what machine learning can reach. It's a very important thing.
Any last word you'd have, Oscar?
Yeah, I would say, even if you're not an engineer or a computer scientist or a mathematician or somebody in hard sciences, you need to know what machine learning is, because machine learning can help you improve your business. It can help you improve your daily work. If you are in health, if you are in finance, if you're in any domain, right? And I believe that companies that are going to survive and be competitive are the ones that leverage machine learning, because in many cases machine learning can do things much, much faster, and in some cases even more accurately than humans. So of course you're going to be more productive if you know what machine learning is, and if you are eager to apply it to your business. So everybody, even if you're not an engineer, computer scientist, learn about machine learning, learn the possibilities that it has, and how it can help you in your daily day. This is not sci-fi anymore. This is real, and it's happening as of today.
Fantastic. Thank you very much for that. So I want to go into what I call a lightning round. It's a little bit personal. It's a little about business. In other words, so the audience gets to know you. Be like 10 seconds type of answer. Just boom, 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 boom. Because we have two of you, Oscar, I'll go to you, then I'll go to Jorge, and then you guys can answer real quick. So, and these are a couple of questions I just quickly jotted down that I wanted to get from you. Number one is the biggest challenge you currently have with data.
Cleaning.
Cleansing the data?
Cleaning data at the scale in a more automatic way, because if not, all your time goes there. I would say that's my major challenge.
Got it. You got anything different, Oscar, or is that your same one too?
I agree with that. And I would say data security and data access as well, because of the same things that you mentioned in terms of ethics and all those things, right? Data access, security, and curation, it's definitely a big one. Yeah.
All right. Oscar, got another one for you. What are you learning about now? What's your learning vehicle? Do you like podcasts? Where do you go to get your information?
I'm not much of a podcast person, to be honest with you. I mostly read either it's books or online. I read a lot of Wikipedia too. In terms of AI and machine learning, I was recently learning about unsupervised learning with categorical variables. I was learning about K prototypes, K modes, and some algorithms like that. In terms of other non-engineering related stuff, I was learning about the theory of evolution by natural selection. I was reading about this book by Richard Dawkins called The Greatest Show on Earth, Evolution by Natural Selection.
First part of that was PhD stuff. I think it just went over my head. But another one on evolution, kind of like Evolution is Sapiens. If you haven't read that one, that's a great one. What about you, Jorge?
Yeah, so I usually use Medium and GitHub. Those are my probably like primary sources for learning.
Yeah.
Of course, books. I'm reading a book on deep learning too. That was a gift from one of my interns in the summer. So
you got the title?
It's called Deep Learning.
Oh, that's pretty easy. All right, fair enough. By who? Who was it by? So,
oh my,
that's all right. If you can't do it, we'll put it in the show notes. If two more questions, and I'll start with you, Jorge, this time. If I wanted to become an ML expert, what's the fastest way to go, or where should I go? What's the fastest way to get there?
The fastest. So I think you need three things. I don't know how fast you can get them. One is the math background. Just to have a very math stat background. Linear algebra. That's one. Second is programming, right? You need to be like very happy programming Python, MATLAB, R, whatever is your scripting language, but to be very proficient. And also the applied aspect, right? To be able to actually, be creative and get some data set and imagine what to do and what to try. Those three things. And I think you can get them in school or outside school, Coursera, books, or just experience in your role, in your job.
All right, fair enough. What about you, Oscar? Same answer, or you got a different one?
I agree a lot with what Jorge just mentioned, and especially the third part, because it's not only having the knowledge and the equations, but having this I call it common sense, which counterintuitively is not so common, I have come to realize. Right? So this kind of creativity, and this becomes like the art or the artistic part of machine learning and data science. So the science is, of course, this math and this linear algebra and optimization problems that you encounter, and that's the mechanical component of machine learning, but also this artistic. In some cases, it becomes even black magic. I call it, right, because just coming up with the right features, and for instance, that's where this kind of artistic component of machine learning comes into picture, which is it's also very important. It can make a lot of a difference in the results you get in the end.
Awesome, thank you. So, easiest question of the day: where can the team reach you guys? So Oscar, where can you be reached, and if you want to get information on the Machine Learning Hub, where you go?
Absolutely. So you can shoot me an email. My email is I guess you can put it on the the notes. It's
I will.
Yeah, OD Lara YE. It's actually kind of complicated to spell, but
okay. Yeah, we'll get it in the machine notes.
The Machine Learning Hub website as well. We are located in San Jose, California, the heart of the Silicon Valley. But we also do have some other machine learning hubs in different places. in Germany, in Toronto, in Beijing in China, Bangalore, and other places.
And same question for you, or any social media outlets that you would reference or push people?
I think I'm on Twitter. My handler is Castañón, Castañón.
All right, we'll get that in the show notes as well. Is that your preferred channel?
Yes, for sure, or LinkedIn as well.
I thank you so much. Gave a lot of information today. Kate Nichols, who does the production, we're going to have to get these guys back on. And next time I'd like to go into more of the how and how machine learning works and the statistics behind it. We'll have to keep it just below PhD level knowledge so I can understand it. But if you could do that, that'd be great. Meanwhile, guys, Oscar, Jorge, thank you very much. Pleasure talking with you guys today. Until next time, I hope everybody enjoyed this. Please take a look at the show notes and let us know what you think. Wheels up. Talk to you next time.
Thanks for listening to the Making Data Simple podcast, where we make data fun. Be sure to visit IBMBigDataHub.com/podcasts to access the show notes and uncover even more great episodes. Remember, the views expressed here are those of the host and its guests and do not necessarily represent the views of IBM. Until next time, over and